Hello and welcome to another video of Circuit Digest. In this video, I'll show you how you can use the GPIO functionalities on the STM8S development board. So in our previous tutorial, we have already learned how to use the GPIO function, how to use the STVD development environment, and also how to compile a simple program and upload it. Now let's proceed with the very basic thing, that is controlling the GPIO pins. As you can see here, we have our development board here. External LED is connected and a push button is connected, and we also have an onboard LED. So what we are trying to do is that we'll be flashing the onboard LED, which is the test LED, this one, and at the same time we'll also be controlling this green LED by pressing this push button. So I can show you this circuit diagram. As you can see, the onboard LED is connected to PB5, that is pin 5 of port B, and we have connected a push button as an input device to PBA, and another LED is connected to PA3, that is port A pin 3, through a current limiting resistor. Now the pin is only 3.3 volts, so it is not mandatory to use a current limiting resistor, so I have avoided it in my hardware connection over here. Now the program is already done, so the program as well as the explanation for it can be found at the link given in the description of this video. This will be the main C file. I will go through each line of this, but before that, let us quickly open the camera and I'll power the device and we'll see how it's actually working before we proceed into the video. So I have my programmer here, which doubles up as a powering module. So I'm just powering the device, and as you can see, as soon as I powered it on, the onboard LED is blinking, and whenever I press this button, whenever I press this button, you can see the LED turning on. So this is what we are trying to program. Now what we are trying to learn from this video is that how to turn on and turn off an output device, and how to read the status of an input device like a switch. Now coming back to the programming section, this is our project file, and under the source file, by default you'll have the main and the interrupt C code. In include file, I have added STM8S.h, STM8S config, and STM8S Gpio. So this STM8S Gpio header files will have all the functions required to declare a Gpio pin and to read it or to write to it. To understand what are the functions that is present inside this and how to use it, you would have to use the user manual. So this is the SPL user manual. Under directories, you can find libraries, and under include, you will see gpio.h. So this is a very useful file if you are trying to use the SPL libraries. So if you see here, you will find all the functions that is supported by this header file. So we have a function to deinitialize, we have a function to initialize, we have a function to read the input pin. Let's say we are initializing a pin, so there are two main things that you have to do. One is initialize the pin, the other is to make it to read from the pin and to write to the pin. So GPIO init is to initialize the pin, and you can see the syntax to initialize the pin, the different parameters, and there are also other functions like read input data, read input pin, and stuff like that. So let's go back to the program and we will start with the main part. So this is just the header file. This is a function I have written to introduce a delay. We'll get to that later, but let's start the explanation from the main part. So in the main part, we start the program by deinitializing port A and port B. That is because we are using only, just give me a second. Yeah. So we are only using port B and port A in this program. So we are going to deinitialize both the ports because there are chances that the previous program is still keeping these pins busy with some other functionality. So it's always a good practice to deinitialize your ports before you start. So I'm deinitializing both port A and port B. And then we'll be declaring port A pin 2 as an input pin. If you can see, port A pin 2 that is A2 is connected to a push button. Now we are going to define this push button as an input pin with a pull-up resistor. It has a weak pull-up resistor. So this line over here is going to tell you that this particular port A, which is the pin number 2 on port A, is going to be an input pin with a pull-up resistor. Similarly, we're going to do that for port A3 as well, port A pin 3 as well, but it's going to be an output pin because we have connected an LED to it. And for the onboard LED, it is going to be port B and pin 5. And if you proceed into the while loop, what we are going to do is we are just going to see the status of the pin. To check if a pin is high or low, we have to use this function GPIO read input pin. We are going to check GPIO port A pin 2, and then we will be uh, making it low whenever the pin is not pressed. So the condition being here is that if the button is pressed, then it means, look at the circuit diagram. So if the button is pressed, we are going to pull A2 to ground. So that means it's going to be in 0, it's going to be in low state. So in that case, we'll be turning on the LED, and if the button is off, we'll be turning off the LED. So by default, the LED will be pulled high by using a pull-up resistor, which we have defined in the program. It's an internal pull-up resistor. And then we have created a delay of 100 milliseconds. Now we don't have an inbuilt delay function, so we are writing this program inside which we have two for loops. One for loop is the actual millisecond value. So if we say delay 100, this 100 gets passed over here. And there is another for loop which will be executing a no operation assembly code. So this is an assembly code which does nothing. So we are just holding our program there for the particular value that we have mentioned over here. So this is how the program works. You can find the complete program in the link given at the description of this video. Make sure you have included the 8S and config and the GPIO header file, and also the C code for GPIOs. So all these header files and how to add this, how to initialize or start a project, I have explained all that in a previous video. I'll put the link of that video as well in the description. So something I had to tell you in the video is that there are much more easier ways to do the programming. For example, it is not fair to tell that every time when you're going to deal with this, let's say every time when you're going to deal with this external LED which is connected to GPIO A pin 3, it's not a fair idea to call this as GPIO A pin 3 every single time. So best practice would be to use macros. So what we can do is we can do define, let's call this green LED, and we can give the value of it as GPIO A pin number 3. So this is going to save us a lot of confusion. So instead of mentioning this, I can directly tell that green LED will be a GPIO pin with push-pull output. Similarly, so again, if you don't know what is a push-pull output is, what is an open drain output is, I would definitely recommend you reading the article, the link given in the description of this video. Again, I can just say green LED here. So I will just write low green LED, and also here write high green LED. Similarly, you can do this for the built-in LED as well as to the input pin. So writing a code like this would save a lot of confusion. So I'll just show you if it is getting compiled. I'll build it. So there you go, 0 error, 0 warning. I can also upload the code and show it to you that everything is working properly. So I'm using the ST Visual Programmer. It's opened. I'll load the code. It's GPIO underscore blink, and then Control P to flash it. And another thing that you should notice over here is that as soon as I have completed my flashing process, you'll see my hardware is just stuck, nothing is happening. This is because I did find this strange, but as soon as I program it, my ST link is not resetting on its own. So I either have to disconnect the power and reconnect again, or do this. Just go to the configuration and click on OK. Now you can see the board is functioning again. So the same thing is happening. So the LED is blinking constantly. Whenever I press this button, the green LED is going to glow. So that's it, guys. Hope you have understood the tutorial. If you have any doubts, please leave them in the comment section and I will meet you in another video. Thank you. Bye bye.